Assalamualaikum to panel, all the panels that will evaluate my FOP proposal. My name is Mohd Idzham Bin Nadzarudin and I am choosing Dr. Idris bin Saad as my supervisor. For, for under his supervise, I choose the topic about heat recovery device to preheat higher viscous fuel for combustion engine, configuration on arrangement of triangular fin. Fossil fuel or petroleum have become an important source to this nowadays and have been used worldwide in many sectors such as in industrial and automotive. Automotive will use an engine combustion engine which burn the fuel to move the shaft so the vehicle will move. One of the products is from the fossil fuel is diesel. So diesel has been used in many sector in automotive, especially in heavy duty, to move it and to operate without using any spark plug in the engine. But there is a problem about the diesel in the fossil fuel because fossil fuel is non-renewable energy and will finish up in future. Therefore, biodiesel is being introduced by the scientists as a replacement for the diesel if there any happen or the diesel finish up in the future. But there is problem about the biodiesel because biodiesel have high viscosity and density compared to the diesel itself, which means it made that the properties of the biodiesel is hard to burn compared to diesel. Therefore, we need something that will be heat up the biodiesel to lower its viscosity so that the properties will almost compatible with the diesel. So, for objective of this effective version is about to design a heat recovery system to transfer heat from exhaust to biodiesel. So, as we know, engines will produce exhaust which consists of gases and wasted heat energy. According to Kelvin Planck's statement, which has been taken from the second law of thermodynamics, it says that it's impossible to convert all the heat energy into the kinetic energy from the engine. It means that it is impossible to achieve 100% thermal efficiency in the engine. So, this wasted energy will be taken out from the combustion chamber and will flow out to the environment, which has been a wasted heat energy. So, this wasted energy is very useful and can be reused to heat up this biodiesel. But there needs a device that can transfer the heat from the exhaust to the biodiesel. Therefore, in this FIP, we will be introduced to designing a heat recovery system for the vehicle to transfer the heat from the exhaust into the biodiesel engine. So it will be lower its viscosity and it will match the properties with the diesel. However, there is limitation in our final year project. So firstly, we are unable to make a face-to-face lab session in the UITM. It is because of the due to the pandemic COVID-19, which has been increased recently and very dangerous to other people. So we have been discussed with our supervisor and did not recommend us to do a lab session for this semester, which will be very hard and need to follow the strict SOP that have been regulated by the ATM. So we limited to the CFD analysis and the simulation for this our final project and to use it to present our simulation for the proposal in December. So we using NC software as a software to make the model base of the heat recovery device and the simulation of the heat recovery device to present and, and as our proposal in this semester. So this is the model base of the heat recovery device that has been designed using the NC software in student version. So this software is free and can be downloaded from the official website. So this is the parameters that have been set to design the heat recovery device body. So for the heat recovery device body, the diameter that we will set about 54 millimeter. For the exhaust is about 70 millimeter. The inlet and the outlet of the heat recovery device about 11 millimeter, and the inlet and the outlet exhaust is set into the 16 millimeter. Furthermore, we need to mesh this model base of the heat recovery device. It is because that this mesh will influence the accuracy of the simulation that will be done in the next step. So, the greater the layer that we put in the meshing model, the greater the accuracy that will be obtained in the simulation. But it will cost a lot of time if the layer is too much, and it will need a high performance processor to run it. So for this mesh, we put 5 layers of the maximum and the two information on the inlet of both heat recovery device and the exhaust to be done in the further simulation. So this is all the parameters and the setup that have been set on the heat recovery device to do the simulation. So for the hot inlet, we put about 200 degrees Celsius, and the cold inlet we put around 50 degrees Celsius. For the most flow rate hot inlet, we put of 0.1024 kg per second, and the cold inlet we put around 0.0016 kg per second. And the material that we use is a copper. And for the cold fluid, we use a diesel liquid, and for the exhaust, we use is carbon dioxide. So these are the results that we have obtained from the heat recovery device simulation through the NC software. The result that we needed is a total heat transfer rate of the outlet outer tube and the inner tube. So as you all can see, we have set the iteration to the 100 for each result to get the graph from the NC software. As we can see that total heat transfer rate in the outer tube, it shows that it's decreasing as the iteration increase and start to constant in a 90 iteration. This shows that the device has achieved a thermal equilibrium and has transferred the heat from the outer tube to the inner tube. For inner tube, we can see that the total heat transfer rate in the inner tube has been decreased as the iteration increase. This is because the inner tube has achieved the thermal equilibrium and the heat transfer rate become lesser as the temperature approaches to the outer tube temperature. So that's all from me for this Effendy proposal presentation. If any panelists have questions or comments, you can contact me personally through WhatsApp or even direct call to me. Thank you for lending your ears and attention for this proposal presentation. Thank you for watching.